So now that you've learned how to build some circuits, let's make some robots now, all right? Okay, so like you all, I'm a maker, and I love building robots. I've been building robots. Hello? Can you hear me? Okay, all right. Okay, so like you guys, I've been building robots for a really long time, and as a maker, one of our primary concern is always cost, right? Like you're trying to build robots, every part costs a lot of money. So I wanted to build some robots, but I didn't want to spend a lot of money. So first thing I did was I wanted to build a two-wheeled robot and be able to ride around and do some cool stuff. So where did I go look? I went and looked in a couple of the sites online and did some research, and I was able to figure out how to use an old wheelchair and convert it into a robot that you can control from your smartphone. And we're going to show you today how to do that yourself. All right? Okay, let's make some robot now. All right, so first of all, why did I use, other than the fact that it was cheap, why did I use? You can make a lot of cool stuff with a used wheelchair, right? And a great thing about a wheelchair is it already comes with a great battery, and it comes with a charger that you can charge it easily. Also, it's pretty inexpensive if you can find good deals online. And I'm going to show you where to go find really good deals, like really good deals. And the great things about it is the mechanical engineering and a lot of the electronics is already done for you. So you can go right into making really cool stuff. And a lot of the parts just comes with it, like you can see here. So where did I find wheelchairs? I went on Craigslist. You can find them on eBay. You can even find it in local pawn shops. And a couple lessons I learned when buying wheelchairs is you want to make sure that they have two drive wheels so you can control independently with two motors. You don't want to get the ones with the one that has its own turning handles. Then you have extra motors to deal with. So you just want to take two drive motors and two casters, all right, like we have here. Another thing you want to pay attention to is, does the battery and the charger work? Because otherwise, that's just going to add more cost. Again, you got to go find batteries, and we'll show you if they're not working, one or the other is not working, where to go find them for a pretty good deal and pretty good cost. All right. So a couple other things you're going to need, and this is a very comprehensive list if you want to do beyond some really cool stuff. But we're going to show you here some basic stuff you can do to get you started and build some cool robots. So first thing you're going to need is some high amperage DC motors. And you're going to need a serial Bluetooth module. You can buy serial Bluetooth module on eBay for $5–10. And then you're going to need a couple tools, obviously, to unassemble and assemble the robot. And if you want to make your robot look really cool, you can get some sandpaper and spray paint, and you can just sand it off and just paint it out, and it looks really cool. One of our other robots that we did, we sandpapered it and spray painted it with like matte black, and it kind of looks like the Batmobile. So you can do that. And you want to buy 10 gauze wire. What that does is it provides enough amperage so you're not burning out the wire and melting things or catching in fire. So you want to do that. And you also want a kill switch. Just in case when you're doing your cool stuff, the robot decides to go crazy on you. So you want to get some kill switch there. Ideally, what you want is one kill switch on the robot, so you can just reach over and just kill it right there. But you can also get a remote kill switch that you can put it in series, so even where the robot is far away and is spinning like crazy, you can just stop it remotely, all right? Okay, so that is really cool to do basic stuff directly from your phone. If you wanted to do more, then you want to use a board that can handle a lot of things. So here we're going to talk about IFC 6410, which is an Android development platform. And it is powered by Qualcomm Snapdragon processor, and Linux support is coming soon, but right now it only has Android. This is great because it has quad-core, 1.7 gigahertz, and it has a bunch of IOs you can use. It has built-in Bluetooth and Wi-Fi. I mean, you can't get any better than this, all right? And you can also use various microcontrollers, like the previous speaker was talking about, to connect to various sensors and other cool stuff. And if you wanted to do some, maybe you want to drive around the robot and put a camera on it to do some computer vision stuff, or you want to just remotely watch what's going on, what the robot is seeing, then you can mount some camera on it too. Okay, moving on. Okay, so now that we've gone through some boring bullet points, now let's go to the fun stuff. So when I first got this wheelchair, it kind of pretty much looks similar like what we have now. So some basic things. All wheelchairs come with some basic joystick on it. As we're entering, I'm sure you saw a couple of the wheelchairs. People were riding around with some cool things on top. Those are some cool use cases we're talking about. So the joystick comes with it. So usually they come with it, and you can use that to repurpose and do cool things. One of the other things they come with is wheel lock, and this is really important on the robot. Ashwin, you want to show the wheel lock? So okay. So right over there on the bottom, right above the wheelchair, usually there's a lock. They look like an L shape, and you can just turn it like that to lock it. So what that means is now the motor are connected to your wheels. You can release it, so you can just push them around or do some testing and to see how they're going. All right. And then another thing we have is a seat release. That's usually on the left or right side of the seat, and it's right underneath. And you can press that and just push it up.
Sure.
Yeah. You push that up, and the seat just pops right off. You spin it, and just push right up. And later, we're going to go over that quickly to kind of show you step by step how to do that. And most of them, on the back, there's a little sleeve. They usually store the chargers there. And depending on the wheelchair, some of them have the connectors hidden below. Nice thing about this wheelchair is the connector is right outside, and we're going to show you how easy it is to connect to your robot. All right. And so once you take the release, spin the chair and pop it off on the side where we're saying cover, that's what it's going to look like. Now it's already starting to look like a cool robot, right? So then depending on the cover, depending on the wheelchair, some of them have nuts and bolts that you need to take off to release. Luckily on this one, it just has Velcro, so it just pops right off. Once it pops off, the first thing you're going to notice are the two giant batteries. Some of them have it combined, some of them have it two separate. Either way is fine, but the standard thing for wheelchairs is they come with 12-volt batteries, pretty much similar to what you have in the car. Right? And same thing goes with your lawnmower batteries. So if they go bad, you can always use that to replace them. The next thing you're going to see on the wheelchair is a circuit breaker. This is very important. Should things go wrong, things are putting too much current, and it may go crazy, so the circuit breaker kicks in. What we're going to do with the circuit breaker is we're going to use this as our main kill switch. This is what I was talking about earlier. And around, you're going to see a bunch of different connectors that connect to the left or the right motor and the controller. Okay? And as you can see, notice here, when you buy it off of Craigslist or eBay, they're going to be pretty dirty because you don't know where they've been, right? So there's all kinds of dust and spider webs and everything. So first thing you want to do is really clean it. So one of the first thing I did was pull out the battery, because the battery, the one I got, the battery wasn't fully charged. So I tried to revive it. First I cleaned it, of course. And then I tried to revive it by really slow charging it. A lot of times, batteries do get revived. Unfortunately, in my case, it didn't, so I had to buy a replacement battery. First I bought I just went to a local auto parts store, and for 30, 40 bucks, you can buy those batteries, lead acid batteries, and you can just replace them and it just works, all right? But the problem with those are because they are lead acid batteries and it can leak, so you can't ship it to Maker Faire. So the thing I had to do was go find a battery that wouldn't leak, it was sealed, and that's what usually they come in standard. So if you're lucky, and if you really pay attention when you're buying, then the battery already come sealed, so you don't have to do anything, and it's ready. In our case, we had to buy a replacement. All right. So once you take all of them out, you really want to clean it so you can work with a clean system. So here, as you can see, our now base is ready. All right. So we cleaned it out, took the battery off, and now it's ready. So next thing you're going to do is, and this is optional, but if you want to work on your table, put your the motor and the wheel on the table and work on it, then you want to pop it off. If you want to just work on the floor, then you can just put it on the side and work on it, right? So here what we did was just put it on the side, took some nuts off, and then they come off. Then we put it on the table, and there's a reason why we want to do that is because all wheelchairs have a safety mechanism. What the safety mechanism is, by default, they all lock. They're locked so you don't go rolling down the hill, right? So, but for us, it's more of a nuisance than the useful, because we don't want to add extra circuitry just to release the brakes and get the robot going. So what we do is just pop the cover, usually just 2 screws on the side, it pops right off, And then there are a couple of Allen screws that you can just, one in the middle and two on the side. You pop them off, and then it just comes right off. And you cut the cable, you're good to go. The brakes are out. Another great thing about this is, once you take the brakes off, the shaft that is sticking out, that was holding the brakes were holding the motor to from stopping, we can use that for optical encoders to measure how fast your robot is going. Now you can use really cool control system loops to really control exactly how you wanted the robot to move. Okay. Another thing, the joystick part here, in this case, the controller and the joystick came combined. A lot of times there are two separate things. There's a joystick and there's a controller hidden underneath the cover. In our case, it was easy, so we just pop a couple screws off, the cover comes off, and on the right-hand side, you see a bunch of wires. You want to recycle as much as possible, and I'm a big fan of that to save cost. And also, a great thing about this is, because this is already designed for the current rating for this system, you don't have to worry about what size of wiring to get and all that stuff. So first thing then you want to do is, once you pop the cover off, is take off with a little plier, take off all the wires, and then here comes the fun part. We put the new batteries in, connect the same connectors that was there before, and you connect the left and right motors just like they were before. And the circuit breaker, remember we were talking about? I put in a little kill switch there, the red one, so in case the robot decides to go crazy, then you want to, boom, hit this thing and it'll just kill it right there. Okay, next. So now comes the motor controller. You can really use any motor controller as long as it supports high amperage. We got a really powerful one called Sabertooth. It supports up to continuous 60 amps and up to peak 120 amps. The great thing about this motor control is also it's regenerative. So when you slow down or when you want to stop, the current goes right back into the battery. So it's very power efficient. So to connect to a Bluetooth unit, we ended up getting the $5 one from eBay, and it's a serial Bluetooth connector called HC05. On that, you just want to set the proper baud rate to match on the motor controller on your Bluetooth device. So we set it to 9600, which is default. So the way you want to connect them is you want to connect the 0 volts of the motor controller to the ground of the Bluetooth module. And then you want to connect the 5 volt to the VCC. And then the TX, which is the output of the Bluetooth, you want to connect to the S1 pin of the motor controller. Once you have that, it's pretty much ready to be powered up. So next thing we want to do is now test. So now that's pretty much it. Now you connect the robot back in. The Bluetooth powers up. Here we're just doing some table test. We're just connecting some power to the controller and connecting the Bluetooth module. And in terms of the app, you can really just go download Android SDK. Once you download an Android SDK, there's an example program called Bluetooth Chat. So you just pretty much open the Bluetooth Chat program, and there's a button on the top that says Connect to Bluetooth, and then it's going to scan for Bluetooth devices around you, and it's going to show up your HC05, or if you have a different Bluetooth controller adapter, then it's going to bring that up. You hit Connect, and you're ready to go. And then we're going to have more on what exact commands to send onto the Bluetooth controller. It's basically 0 to 255, and it's just a byte you send to control each motor. Okay? And so that's how you do it. Now let me quickly go over which pins to connect, the motor controller part to the motors and the power. So the middle two part on the motor controller are for battery, right? So plus you want to connect to the red, and the minus you want to connect it to the black. And then there's M1A and M1B, which are just one or the other ends of the batteries. And there's M2A and M2B, that's the other two ends battery. So you just want to connect one of them to the left motor and the M2 to right motor, and that's what I did. And if you end up doing it backwards, then you just go and change in the software, and it's easy as that. And then you can run a quick table test. For that, what you want to do is put something underneath the robot, so you just lift it a little bit, and then you run your program, and as you do left, right, front, back, you're going to start seeing the wheels rotate, and accordingly you know whether it's moving in the right direction or not. Now, once you do that, you're pretty much ready. You pop everything back on. You can even, if you can be really slick about it, really hide it, and you can do a rogue, cool, like a ghost wheelchair if you want to spook your grandma off or something. Okay. So that is great. And I'm going to call my friend Ashwin over here to talk about if you just want to do just basic control, then that is great. But if you want to do even cooler stuff, like Ashwin is going to talk more about some of the really cool things you can do with IFC 6410.
Mic testing, oh, it works. All right, thank you very much, Nahesh. That was really good. So you learn how to control a robot or a wheelchair manually, right? So we'll do the next cool thing. How about the robot moves by itself? It sees people, it avoids people, it can talk to people. How do you make that happen, right? You take a really smart processor, or microcontroller, or maybe a mobile phone chipset, right? You connect it to the robot and you write your programs to do facial recognition that's going to see people, recognize people, and talk to you, or basically not hit into you when it's roaming around, right? But to do this, you have to be very careful. Data sheets, you've got to read your data sheets when you take a look at the motor driver or the processor, maybe an Arduino or an IFC 6410, which is powered by a Qualcomm Snapdragon processor, right? Okay, as I was saying, you have to be very careful with hardware when you're connecting two hardwares together. Snesh already told you that the motor driver that we are using works at really high voltage and high amperage. Right. If you take a look at the datasheet of the Sabertooth, it says that it can take up to 3.3 volts and 5 volts, right? But here we have this board, which is the IFC 6410, powered by a mobile processor. Can anyone in the crowd tell me what voltage does mobile processors work at? 20 volts, 5 volts, about 2, 3? Actually, mobile processors are really low voltage, really low current. They work at 1.8 volts. Very low voltage. Why? Can anyone tell why? You want your phones to last for 2 days. You want your phones to last for a day. If you run it at 3.3 volts or 5 volts or high current, it's not going to last too long, right? So now that we have figured out your board works at 1.8 volts, now what's going to happen if you connect the board, which is 1.8 volts, directly to a Sabertooth motor controller, which is working at 5 volts? What is going to happen? It's going to blow up your board. You don't want that to happen, right? So what you do is you're basically going to use another hardware, which is going to convert your Sabertooth's 5 volts or 3.3 volts down to 1.8 volts, right? All you have to do is go online, Google for level shifters or voltage level shifters. What we did was we went to Adafruit, the SparkFun, just Google over there. You'll get a nice breakout board for about $10 or $15. Once you get that up, you've got to make these connections. The voltage driver is pretty simple, right? Let's assume that this is a voltage driver, right? It's a small block diagram. It has input and it's got output. Input is around 1.8 volts. That's where you're going to connect the GPIOs of this guy. Output is 3.3 volts or 5 volts that goes into your Sabertooth motor controller, right? But apart from connecting the signals, you have to power it too. You have to tell it what voltage they run at, right? So left side there is Vin, which you give 1.8 volts, saying that everything on this side is going to be 1.8 volts. On the right side, you give either 5 volts or 3 volts, depending on what voltage you want. So you give 3.3, for example, everything on this side is going to be 3.3 volts. You make those connections over here, and you already saw or heard Sneha say that this Sabertooth motor controller works off of UART, serial port, right? So the left side, what you do is you pick up one of the pins of the IFC 6410, which is a UART transmit pin, and we have noted down over here is pin number 28 is a UART transmit pin. You connect that to the left side of your motor driver. The right side goes to, the left side is connected to the IFC 6410, and the right side goes to the motor controller. Now you have a proper connection. It's all safe. You're not going to blow up your motor driver, or you're not going to blow up this thing, right? Now, The IFC 6410 comes with a adapter, wall adapter, right? You can't plug it into a wall adapter and have the robot moving, right? What you have to do is you have to connect the battery to this guy so that it powers up. And you already heard Snehal say that the battery works at what voltage? 24. You've got two batteries in there, 24. How do you bring 24 volts down to 5 volts? Right? There is a voltage driver over here, voltage regulator here, which takes in 5 volts and drops it down to 1.8. But this guy needs 5 volts. For you to get 5 volts out of the 24 volts battery, what you have to do is you have to go online again and buy a voltage regulator off the shelf. What you see in the picture over here is where the screwdriver is. That's the voltage driver. It's a variable voltage driver, which means that if you give it 24 volts, you can vary it from, say, 23 volts all the way down to, say, 3.3 volts, depending on the data sheets of that particular part. So here what we are doing is we are being very careful in measuring the output of the voltage driver. One side we have given, again, this is a voltage driver. One side we are giving the battery, which is 24 volts. And the other side we are trying to take out 5 volts. And how you do that is there's a small potentiometer on the voltage regulator board. You turn that carefully and monitor your multimeter and see that it gives 5 volts. Once it is giving 5 volts, you're good to go ahead and connect your IFC 6410. Now the IFC 6410 is properly connected to your motor driver. It's properly hooked up to get power. It's up and running. So now I'm going to hand it over. It's all software work from here. Snesh is our software expert, so he's going to tell you what to do next.
Thank you, Ashwin. So now that you guys have powered up the IFC 6410, it's again going to boot up in Android, right? So now what do? So you can get like any serial to Bluetooth program, or you can get or you can just write a basic serial program, right? So what you want to do on that is you want to do ADB shell and go to the command prompt of the Android shell, and you want to make sure that you have proper access to the serial port. Basically, if you do search ls tty/dev/tty asterisk, you're going to get a whole list of different ports. In IFC 6410, the port's going to be TTY SSL2, right? So you just want to go there and do -777, and it should set up the proper read-write access. So now that we have that in your application, what you're going to do is you're going to select that port. That's your serial port where the things are going to go out of, and set it the proper baud rate, just like we did for the Bluetooth adapter. And now we're going to show you with a couple buttons how to go. This is version 1 of the application, where you can just click through, go faster or slower. But if you want to make it very responsive, then what you would want is a joystick. Now, buying another joystick is extra expense, so we're going to create a virtual joystick, right? So if you just go online and search for joystick view, you will find a bunch of different sample code that you can use. So just plop one of in there, and in this case, if you release your finger, it's going to go in the center, and you want to map that to just call a stop function. And if you put it to left or right, accordingly, you want to map it to the left, or go front, back functions, and then that will make your robot go faster or slower, left or right. Okay. And then how do you want to connect from your phone to the IFC 6410? Like I said before, the cool thing about IFC 6410 is that it comes with built-in Wi-Fi and Bluetooth, so you don't have to attach anything. So here I'm using Wi-Fi to connect to it, but you can also use Bluetooth. Pretty much go on your application, open a socket server on your IFC 6410, and then write a socket client on your phone. And then the IFC 6410 is going to start broadcasting as a server and be accepting connection. Very simple socket communications. Now that you have that, quickly going to summarize how things are all connected, right? So on your smartphone side, we're going to have, so I have too many smartphones. Okay. So on your smartphone side, you're going to have a basic joystick application. Here, we're going to use something else. So not sure if you guys can see this, but here we just have a couple buttons here, right? And that's what we're going to use. So for us, this is our joystick for now. And then according to what front or back signal you give, it's going to send that over socket, over Wi-Fi or Bluetooth to the IFC6410. IFC6410, like Ashwin was mentioning before, is going to connect to the level shifters and transfer that data into your Sabertooth, and that's going to create motion. Now we're going to give a quick demo of how this is going, how it runs around. So everything's set up. Is it blinking? Okay. Same one? No, I think it's fine. Okay. Wheel lock? All right, I was just checking the wheel lock. All right, so camera button. Is this it? All right. So it's difficult to see, but all right. So we have your application here. So when you do this, it finds the device. You connect to it. It says connected, right? So now it's connected. It's kind of difficult to see. So, but I'm going to start hitting forward, and it's going to start moving forward. I don't want to make it really go fast because the lack of space, but I'm going to make it stop for now. Okay. All right. So that's how you make a basic, very cheap $100, $150 off of Craigslist wheelchair. Take out all the things you don't need and just buy a couple different parts and write a simple smartphone app to control and make your autonomous robot. Before we go, I want to let you a couple things. So, at the Qualcomm booth today, we're giving away 5 robots. Okay, so please go there. It's a smaller robot for you to play, not quite the wheelchair, because it'll be difficult to ship, you know. But go to Qualcomm booth at 2 o'clock. They're going to be doing raffles. So after this, you can follow us, or you can just head over and quickly sign for the raffles. And you can. There are 5 robots that they're giving away. You can use a smartphone to control that. Also, Inforce is having a special for the IFC6410 at 50% off. Normally, it costs about $150. Right now, they're selling it at $75. You can use this to write any smartphone application and test it out, or build really cool robotic applications like we did. Okay, thank you very much. Really appreciate your time, and hope to see you in the Qualcomm booth. Thank you.